Welcome to another episode of Terry's Notes. Today we are going to be looking at the periodic table and periodicity. The modern periodic table is a chart containing the elements arranged in order of increasing atomic number. So this is how the periodic table is currently arranged in terms of increasing atomic number. A vertical column called a group contains elements with similar properties. So the vertical columns are called groups and they usually have similar chemical properties. A horizontal row is called a period. The atomic number of the elements in a period increase from left to right along the row. Before the periodic table was created, several attempts were made to classify the elements into a useful way. Dobereiner arranged groups of 3 elements with similar properties into triads. Example, lithium, sodium and potassium had similar properties. Mendeleev arranged the elements in order of atomic number. And what he did, he left gaps for elements that weren't discovered as yet. He could predict the properties of those undiscovered elements. This is just a sample of what Mendeleev's periodic table looked like. And if you would notice, he left gaps for elements that had not been discovered as yet. But he can predict the physical properties or the chemical properties of these missing elements. This diagram gives the current periodic table. And we have groups, which are these. The groups are the vertical columns. So this is group 1. This is group 2. And we continue going to the right. So we have up to group 7 on the side. And the last group is called group 0 or sometimes group 8. And the horizontal rows are what we call periods. So these are groups and these are called periods. The elements in the periodic table are arranged in terms of atomic number, as indicated earlier. The horizontal rows of elements are called periods, and vertical columns of elements are called groups. Now let us look at some trends in some of these groups. We're going to be looking at group 2. Group 2 elements have atoms with 2 electrons in the outermost occupied shell. Okay, and these are the elements in group 2: beryllium, magnesium, calcium, strontium, barium. And these are the electronic configurations of each of these elements. And if you will notice, you will see that the last shell of each of them contains 2 electrons. So the last shell will tell you which group the element belongs to. The group 2 elements are called the alkaline earth metals. As the group is descended, the atomic radii increases. What this means is that as you go down the group, the size of the atom increases. The valence shell electrons, or the outermost shell, move further away from the nucleus and are therefore held less tightly. So remember, in an atom, you have the nucleus, and then we're going to have electrons. So we have electrons here. The nucleus is positively charged and electrons are negatively charged. As you move down the group, the size of the atom gets bigger and bigger. right? And therefore, remember, the nucleus is what is attracting electrons. So if the electrons are moving further and further away from the nucleus, it means that they're being held less tightly. The ease of ionization increases down the group. Ionization is the process of losing an outer shell electron. So therefore, as you go down the group, the outer shell electrons are lost more readily. And that explains why the reactivity increases down the group. So reactivity with oxygen, water, and hydrochloric acid increases down the group. Let us look at the reaction with water. So the example we'll use is magnesium. So clean magnesium reacts with cold water to produce magnesium hydroxide and hydrogen gas. So Mg plus 2H2O produces MgOH taken twice plus H2. Now you get a different reaction when magnesium reacts with steam. What you get this time is magnesium oxide and hydrogen gas. These are common questions that you could get. So magnesium and cold water will give you magnesium hydroxide, and magnesium and steam will give you magnesium oxide. So Mg plus H2O produces MgO plus H2. Calcium reacts fairly vigorously with water to produce a white precipitate of calcium hydroxide and hydrogen gas. So Ca plus 2H2O produces CaOH taken twice plus H2. You need to be able to write these equations. And the next thing is the reaction with oxygen. Magnesium, calcium, and barium, they tarnish in air. What this means is that they readily form an oxide layer around them. So in order to get magnesium to burn, you will have to scrape the oxide layer off of the magnesium before it can be burnt in oxygen. And the reaction is 2Mg plus O2 produces 2MgO. We get magnesium oxide in this case. And this reaction occurs with a blinding white flame. Calcium does not start burning easily, again because of the oxide layer, but when it does, it bursts into flame to form calcium oxide. So 2Ca plus O2 produces 2CaO. Reaction with hydrochloric acid. Now remember I said that the group 2 elements are alkaline earth metals. So a metal plus an acid will give us a salt and hydrogen gas. So magnesium will react with hydrochloric acid to produce magnesium chloride and hydrogen gas. So Mg plus 2HCl produces MgCl2 plus H2. Calcium, we get a similar reaction. Calcium plus hydrochloric acid will give us calcium chloride and hydrogen gas. So Ca plus 2HCl produces CaCl2 plus H2 gas. Now this table summarizes the reaction between magnesium and calcium. Magnesium is higher up in the group and calcium is lower down in the group. So the reaction with water, in the case of magnesium, the reaction is very slow with cold water but is vigorous with steam to form magnesium oxide and hydrogen. In the case of calcium, the reaction is vigorous with cold water at first but slows down as the sparingly soluble hydroxide is formed and hydrogen gas is also produced. The reaction with dilute hydrochloric acid. So the acid in this case we are talking about is HCl. In the case of magnesium, you have a rapid reaction. You get magnesium chloride being produced as well as hydrogen gas. For calcium, it's a very rapid reaction with dilute hydrochloric acid. Calcium chloride is produced and hydrogen gas is produced. In the case of the reaction with oxygen, in air, the layer of oxide forms, preventing further oxidation. A brilliant flame is produced as magnesium oxide is produced. In the case of calcium, the layer of oxide that forms around the calcium prevents further oxidation. So what we are saying, as we go down group 2, reactivity increases. And the reason for this is that the atomic radii increases down the group. The attraction of the nucleus on the outer shell electrons decreases down the group, and therefore the outer shell electrons are lost more readily. And this is the reason why reactivity increases down the group. Let us now look at trends in group 7. In group 7, we have fluorine, chlorine, bromine, and iodine. And we have the electronic configuration of each of them. We will notice that in the last shell, the outermost shell, we have 7 electrons. All right. Now, in group 7, the fluorine, chlorine, bromine, and iodine are called the halogens. We also need to look at the physical properties of these elements. Fluorine is a gas, chlorine is a gas, bromine is a dark red liquid, and iodine is a dark gray solid. So what you would notice is that as you go down the group, the physical state changes from gas to liquid to solid. Now, the group 7 elements exist as diatomic molecules. What this means is that they exist as, in the case of chlorine, it exists as Cl2. In the case of bromine, it exists as Br2. And in the case of iodine, it exists as I2. So you would not see a chlorine atom existing by itself. It usually exists in combination with another chlorine atom. In the case of bromine, this will also exist as a diatomic molecule, and iodine will be the same as well. Now, because they exist as diatomic molecules, it means that between these molecules, we will have some form of attraction between them. Now, this force of attraction between the diatomic molecules are very weak, and they are called van der Waals forces. Now, as you move down the group, the strength of these forces increases. And what this does is it forces the molecules to move closer together. And it is because of this, you move from a gas to a liquid, then to a solid. Alright, so this is why the physical state changes from gas to liquid to solid. And it also explains why the melting point and boiling point increases down the group. So let me just recap. The group 7 elements, they exist as diatomic molecules. Because they exist as molecules, we have weak intermolecular forces between them, and these forces are called van der Waals forces. As we move down the group, the strength of the forces increases and brings the molecules closer together. And that is why we have a change in physical state as you go down the group. And that is why the melting point and boiling point increases down the group. So what I am saying is that you have a chlorine molecule, you have a next chlorine molecule, you have a next chlorine molecule in chlorine gas. Now between the molecules, you will have weak forces, and these dashed lines represents the weak forces, which are known as van der Waals forces. And what I'm saying is that as you go down the group, the strength of these forces increases. Now, group 7 elements are oxidizing agents. Right? The oxidizing strength decreases as you go down the group. Now, when something behaves as an oxidizing agent, it is itself reduced when it behaves as an oxidizing agent. Right? Now, oxidation is the loss of electrons. So let's say chlorine. Chlorine is able to form the chloride ion, but an electron is lost in the process. Right? So if chlorine is acting as an oxidizing agent, it is itself reduced. So chlorine has an oxidation number of 0. The chloride ion has an oxidation number of -1. And we know that a decrease in oxidation number is called reduction. Right? So when chlorine acts as an oxidizing agent, it is reduced. So it goes from oxidation state 0 to -1. Now an element higher in the group displaces an element lower down in the group. Now this is a typical question that CXC likes to bring. So for example, if we take chlorine gas and bubble it through a solution of sodium bromide, bromine will be displaced. The observation is that a reddish brown liquid will form. You also need to be familiar with this equation. So Cl2 plus 2 NaBr produces 2 NaCl plus Br2. So just remember what the elements are. You have fluorine, chlorine, bromine, and iodine. And what we are saying is that the one higher up in the group is able to displace the one lower down in the group. So chlorine is here, and chlorine is able to displace iodine. Chlorine can also displace bromine, but bromine cannot displace chlorine. It's always the one higher up in the group displacing the one lower down in the group. Now we need to look at period 3. And remember, the period are the list of elements that go horizontally. So in period 3 we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Now if we look at the electronic configuration, we notice that the outer shell electron is different for each one. But what you will notice is that you have 1, 2, 3 electron shells. So just by looking at the electronic configuration, we can tell which period an element belongs to. And earlier we said that the last number will tell you which group it belongs to. Now, sodium, magnesium, and aluminium are metals, and they have metallic characteristics. Silicon is semi-metallic, or sometimes referred to as a metalloid. It shows both metallic and non-metallic characteristics. Phosphorus, sulfur, and chlorine are non-metals and show non-metallic characteristics. So the general trend as you move across a period is from metallic to non-metallic character. Now you need to remember the first 20 elements of the periodic table, and this is a trick that I usually tell my students. You should learn them by groups because it is easier to remember the electronic configuration. So in group 1, all you need to remember is lithium, sodium, potassium, and we know we start off with 2,1, then it should be 2,8,1 and 2,8,8,1. In group 2 we have beryllium, magnesium, and calcium, so we go 2,2, 2,8,2 and 2,8,8,2. In group 3 we have boron and aluminium, so we start off with 2,3, then 2,8,3. In group 4 we have carbon, silicon, which is 2,4, 2,8,4. In group 5 we have nitrogen and phosphorus, that is 2,5 and 2,8,5. In group 6 we have oxygen and sulfur, which is 2,6 and 2,8,6. And in group 7 we have fluorine, chlorine, which will be 2,7 and then 2,8,7. And in group 8, or group sometimes referred to as group 0, we have helium, neon, and argon. We just have 2, and then we have 2,8 and 2,8,8. Now in group 8, these are the noble gases, and you need to know that they are very stable. And the reason for this is that the outer shell electron is filled. It has 8 electrons in the outer shell. Now this partial periodic table here shows this is period 3. Notice in electronic configuration we have 3 numbers. This is period 2. Notice we have 2 digits for each electronic configuration. And like I said before, the last number will tell you what group it belongs to. So this belongs to group 1, this belongs to group 2, this belongs to group 3. Now, if you are given the electronic configuration of an element, you can determine the atomic number, the group number, and the period. For example, suppose you are given an electronic configuration of 281. Just by looking at this number or this electronic configuration, I can determine what group it belongs to. The last number will tell me what group it belongs to. It's 1, so therefore I know this element belongs to group 1. We have 3 numbers, 1, 2, 3. So therefore I know it belongs to period 3. I can also determine the atomic number. The atomic number is simply 2 plus 8 plus 1, which is 11. So to get the atomic number from the electronic configuration, we just need to add the digits that make up the electronic configuration. And this element, as we know, is sodium. Now, as I mentioned before, the noble gases occupy group 8 and are very stable. And you will notice that they have 8 electrons in their outer shell. When elements react, they attempt to achieve a stable structure by gaining or losing electrons, or by sharing electrons, right? And in so doing, they achieve a stable structure